Hi ma'am, this is P. Akila from Computer Science Engineering in specialization of AI and ML. Today's my topic is Dempster-Shafer's theory in artificial intelligence. This subject is dealt by Dr. M. Soumya ma'am. Then next, the history of the Dempster-Shafer's theory. First of all, Dempster and the Schaeffer are the two scientists. Dempster-Shafer's theory is first introduced by the author P. Dempster in 1967 in the context of the statistical inference. The theory was later developed by the Schaeffer. He is the student of the Dempster. In 1976, into the general framework for the modeling epistemistic. Epistemistic means which is related to the knowledge, uncertainty, and the mathematical theory of the evidence. Then next, introduction. Introduction means definition. Dempster-Shafer's theory is the mathematical theory of the evidence, which allows one to combine evidence from different sources and make decision based on it. And this, which is designed to deal with the distinction between uncertainty and the ignorance. Here, the uncertainty which is we don't know, and the ignorance. Ignorance is and the lack of knowledge. Then next, it allows the representation of the beliefs and the degrees of the uncertainty without requiring the price probabilities. Price means a clear and the probability means the chance of the event to occur. This was released because of the following reason. Bayes theory. Here the Bayes theory means it is the mathematical formula for the conditional probability. The formula is the P of A by B is equals to P of B by A into P of A divided by P of B. Bayes theory is the only concerned probability about single evidence. Bayes probability cannot be described ignorance. Then next, key concepts of the Dempster-Shafer's theory. The theory is based on the concepts of belief functions and the basic probability assignments, which means a BPA. Belief function quantify the degree of the belief in proposition based on available evidence. The basic probability assignments discriminate the total belief over subset of the frame of discernment. Discernment means the ability to judge well. Then next, the frame of the discernment. Here, a set of all possible outcomes are the hypothesis, which is denoted by the theta. It represents the universe of the possible states relevant to the particular problem. Each subset of the frame represents a potential outcome or the event. Then next, basic probability assignment, a function that assigns a probability to each subset of the frame, where the mass reflects the belief specially assigned to the each subset. The total sum of BPA values must be equal to the 1, ensuring consistent belief allocation. It allows representation of the uncertain information by focusing on subject rather than the individual incomes. Then next, uncertainty interval. Here the uncertainty have a belief and the feasibility being supported by the evidence or unknown. Based on the support from the evidence, belief interval based on the unbelief rejection, which is not a unbelief evidence. Consider all possible events and the outcomes. Events and possible outcomes. Belief will lead to the belief in some possibility by bringing out some evidence. Feasibility will make evidence compatible with possible outcomes. Then next, belief and the falsibility functions. Belief function represents the degree of the belief that represents a specific hypothesis. For subset of A, belief of A is equals to sum of masses of all subsets of A, and the feasibility functions measures the extent to the with the hypothesis is feasible. For subset of A, feasibility of A is equals to 1 minus belief of negation A. Then next, Dempster's rule of combination. It's a rule of combining evidence from the independent sources to produce new and aggregate mass functions. The rule merge functions while taking into the account conflict information. This rule is especially useful in situations where the evidence from the different source may partially independent supports different hypotheses. The next, the combination rule. M12 of A is equals to summation of x intersection of y is equals to A power m1 of x into m2 of y divided by 1 minus summation of x intersection y is equals to 5 power of m1 of x into m1 of y. Here the m of A is the combination of the two individual sources or the mass functions for the hypotenuse A. The denominator is the normalization factor 1 minus k. Here the k is the conflicting evidence. Evidence source must be summed to the equal. The next example for the Dempster-Shaffer's theory. Let us consider a room where the people are present in A, B, C and the D. Suddenly the lights go out, and when the lights come back, B has been stabbed in a back by a knife, leading to its death. No one come into the room and no one left the room. We know that B has been not committed to the decided suicide. Now we have to find out who the murderer is. To solve these three following possibilities, we have either A or C or D has killed by, and either A, C or C, D or A, C have killed him, or the next or the three of them have killed him. A, B, C, D, and none of them have killed him. Let's say the next, the set of possible conclusion P, P1, P2 and so on P of n. The next, where P is the set of possible conclusion and cannot be exhaustive, that is, at least one must be true, and P must be mutually exclusive. The power set will contain 2 power n elements. Here the n is the number of elements in the possible set. For example, power set of P is equals to A, B, C. Then the power set is given 0. 0 is the null value, and the A, B, C, A, B, B, C, A, C and A, B, C is equals to 2 power 3 elements. Here the 3 is the number of elements in the set. So that is equals to 8 elements. The next, mass function. It is interpretation of M of K or B. That is, it means where is evidence for the K or B, which cannot be divided among more specific beliefs for K and B. Next, belief in K. The belief in elements K of power set is the sum of masses of elements, which are subsets of the K, and this is explained through an example. Let's say K is equals to A, B, C. The next, belief of K is equals to M of A plus M of B plus M of C plus M of A, B and plus M of A, C plus M of B, C plus M of A, B, C. And the feasibility in K, it is the sum of masses of the set of intersects with K. That is, P of K is equals to M of A plus M of B plus M of C plus M of A, B plus M of B, C plus M of A, C plus M of A, B, C. Then next, another example for the Dempster-Shaffer's theory. Here we have two sensors are used in detect user location in an office. The location of the interest are first one cave, the user desk and the meeting room and the lobby in the building. Here the lobby means which means a entrance room. The next sensor 1 cave and the user desk, and sensor 2 covers the meeting room and the lobby. The frame of discernment hypothesis allows the combination. Each sensors assigned belief has the manual function. The next, an uncertainty is assigned to the ignorance hypothesis theta. That is desk and the cave and the meeting room and the lobby. Then next, applications of the Dempster-Shafer's theory. Here the applications, this will mainly used in artificial intelligence and the decision making system. This theory also finds in the image analysis and the medical diagnosis and the risk assignments. Then next, we will discuss about the advantages of the Dempster-Shafer's theory. Dempster-Shafer's theory provides a flexible approach to modeling uncertainty compared to traditional probability. It handles partial and the uncertainty information, can combine evidence from multiple sources, flexible. Then next we will discuss about the limitations of the Dempster-Shafer's theory. One limitation is the computational complexity involved in combining multiple beliefs functions. The theory can become one widely when dealing with large frames of discernment. And additionally, the interpretation of belief and the flexibility can something be ambiguous. Here the ambiguous means which is clear because it understands in multiple ways. Then next, conclusion. The Dempster Shuffles is a powerful tool for the reasoning and under uncertainty and imagining incomplete information. Its applications span various domains, making it relevant in both theoretical and practical contexts. Then next, thank you. Thanks for giving this opportunity, ma'am, to explain about the Dempster Shafer's theory.